Morning students. Today let us learn how to represent a chemical reaction as chemical equations. What is a chemical equation? It's a symbolic representation of a chemical reaction using symbols and formulae. As we have seen in our earlier class, when magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. This chemical reaction can be written in the form of word equation. That is, magnesium plus oxygen gives magnesium oxide. Substances that undergo chemical change in a reaction, that is magnesium and oxygen, are the reactants on the left hand side. The new substance magnesium oxide formed during the reaction is the product on the right hand side. In between the reactants and the products, the arrow is placed and its head pointing towards the product and shows the direction of the reaction. The chemical reaction is represented in words, so it is a word equation. Now, how can we write the chemical equation in a more concise form? Now let's learn how to convert a word equation to skeletal equation using symbols of elements and formulae of compounds, which can be written as Mg plus O2 gives MgO. Now count and compare the number of atoms of each element on the reactant side and the product side. Magnesium has one atom on the reactant side and one atom on the product side. But oxygen, two atoms on the reactant side but one atom on the product side. So the number of atoms of each element on both the sides of the arrow, that is the reactant and the products, is not the same. So it is an unbalanced equation or skeletal equation. Why do we call it an unbalanced equation? Because it does not satisfy the law of conservation of mass. Let's recall its definition. Mass can neither be created nor destroyed in a chemical reaction. So the number of atoms of each element on the reactant side should be equal to the number of atoms of each element on the product side. Now let's try to balance the equation on both reactant and the product sides. Let's start with magnesium. It has one atom on both the reactant and the product sides. So we will move on to oxygen. It has two atoms on the reactant side and only one atom on the product side. We cannot make any change to the formula inside the boxes. So we add a smallest whole number coefficient, that is 2, to the product side, which becomes applicable to both the magnesium and oxygen atoms in magnesium oxide. Let's take a look at the number of atoms on both the sides. Magnesium has one atom on the reactant side and two on the product side. Oxygen has two atoms on both reactant and product side. The equation needs a little more work to balance the magnesium atoms. In order to balance the magnesium atoms, let us add the smallest coefficient 2 to the magnesium atom on the reactant side. Now count the number of atoms on both reactant and product sides of the equation. The number of magnesium and oxygen atoms is 2 each on both reactant and product side. The number of atoms of each element remains the same before and after the chemical reaction. Hence, it satisfies the law of conservation of mass. It is termed as a balanced chemical equation. To summarize what we have learned so far, first we write the word equation, then we write the skeletal or unbalanced equation. To satisfy the law of conservation of mass, we need to balance the chemical equation. Now let's look at another example on representing the chemical reaction between zinc and sulfuric acid. Let's learn to write a chemical equation for the chemical reaction between zinc and sulfuric acid. To start with, write the formula for zinc sulfuric acid as Zn and H2SO4 on the reactant side, which react to form zinc sulfate and hydrogen, represented as ZnSO4 and H2 on the product side. Count the number of atoms of each element on both reactant and product side. Zinc Zn has one atom on both reactant and product side. Hydrogen has two atoms on both reactant and product side. Sulfur has one atom on both reactant and product side. And oxygen has 4 atoms on both reactant and product side. The atoms of all elements remains the same on both the sides. Hence, it is a balanced chemical equation. Let's learn another example for the chemical reaction between iron and water, that is steam. To start with, write the formulae for iron water as Fe and H2O on the reactant side, which react to form iron oxide and hydrogen, represented as Fe3O4 and H2 on the product side. Step 1 is to draw boxes around each of the formulae and do not make any further changes to the content of the boxes. Step 2. List the number of atoms of each element present in the equation. Iron has 1 atom on the reactant side and 3 atoms on the product side. Hydrogen has 2 atoms on the reactant side and 2 atoms on the product side. Oxygen has 1 atom on the reactant side and 4 atoms on the product side. The number of atoms on reactant and the product side are not equal. Hence, the equation is unbalanced. Step 3. Select the compound which contains maximum number of atoms. It may be a reactant or product. Here it is Fe3O4. In that compound, select the element which has the maximum number of atoms. Here it is oxygen. Now, let's move on to balancing the oxygen atoms on the reactant and product sides. Oxygen has 1 atom on the reactant side and 4 atoms on the product side. So, we add smallest number coefficient, that is 4, to the reactant side, where the 4 is applicable to both hydrogen and oxygen on the reactant side. Take a count of atoms of all elements. Iron has 1 atom on reactant side and 3 atoms on the product side. Hydrogen has 8 atoms on the reactant side and 2 atoms on the product side. Oxygen has 4 atoms on both reactant and product side. Let's balance the iron and hydrogen atoms. Step 4. Let's equalize the number of hydrogen atoms on both reactant and product sides. Hydrogen has 8 atoms on the reactant side and 2 atoms on the product side. So, we add smallest number coefficient, that is 4, to the hydrogen on product side. Again, take a count of atoms of all elements. Iron has 1 atom on reactant side and 3 atoms on the product side. Hydrogen has 8 atoms on both reactant and product side. Oxygen has 4 atoms on both reactant and product side. Now, let's move on to balancing the iron atoms. Step 5. Let's equalize the number of iron atoms on both reactant and product sides. Iron has 1 atom on the reactant side and 3 atoms on the product side. So, we add smallest number coefficient, that is 3, to the iron on the reactant side. Again, take a count of atoms of all elements. Iron has 3 atoms on both reactant and product side. Hydrogen has 8 atoms on both reactant and product side. Oxygen has 4 atoms on both reactant and product side. Step 6. The atoms of all elements are equal on both reactant and product sides. Hence, the chemical equation satisfies the law of conservation of mass and can be called a balanced chemical equation. This method of balancing chemical equation is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Strategies for balancing a chemical equation. Balance compounds first, elements last. Balance one compound at a time. Only add coefficients, never change subscripts. If hydrogen and oxygen appear in more than one place, attempt to balance them last. Polyatomic ions such as sulfate, nitrate, carbonate can often be balanced as a whole group. Always double check after you think you are finished.